Solve applications about distance, rate, and time. So we're going to look at two problems for this. The first one being that a small fishing boat goes 36 miles against the current in a river in the same amount of time that it goes 44 miles with the current. If the rate of the boat in still water is 20 miles per hour, find the rate of the current. So this one I have worked out on the paper. We're going to talk through it. So first off, there's a couple key things to note. First being, if I have this rate in still water of 20 miles per hour, if I go against the current, that means it's going to slow me down, so we subtract off the current speed. If I'm with the current, then I take that 20 and I go even faster because it's going to be behind me and it's going to fuel me to go faster. It's going to push me forward. So against the current, they're able to go 36 miles in a distance. With the current, we're able to go 44 miles in the same amount of time. Well, that means that if I know that distance is equal to rate times time, if I solve for time, I get distance divided by rate is equal to time. So distance divided by rate gives me my time column. Excuse me. So I get 36 divided by 20 minus x for this top one, and 44 divided by 20 plus x for this bottom. So distance divided by rate, this column. It tells me something else that's key to solving this problem. They're able to go these distances in the same amount of time. So these two things are equal. Therefore, we set them equal to each other. We then cross multiply. So 20 plus x times 36 gives me 720 plus 36x. 20 minus x times 44 gives me 880 minus 44x. Add the 44x over. Subtract 720. Leaves me with 80x equals 160. Divide both sides by 80, and x equals 2 miles per hour. That means the current is 2 miles per hour. Well, what does that mean in terms of his rate against the current? 20 minus 2 would be 18 miles per hour. If he goes with the current, 20 plus x is with the current. Let's look at a second one. Similar vein. James and Pat are driving from Atlanta to Jacksonville, a distance of 310 miles. James, whose average rate is 5 miles per hour faster than Pat's, will drive the first 130 miles of the trip, and then Pat will drive the rest of their way to their destination. If their total driving time is 5 hours, determine the average rate of each driver. So the first thing I recommend with any problem is putting together a chart. So we're going to do the same thing on this problem. So first off, here's our second problem, and we need a table. There's my best table. We have James and we have Pat. And we know we're talking about a rate times time equals distance problem. Here's some things we know. James is going to drive 130 miles. Pat's going to drive the rest of the way. Well, it told us the total trip was 310 miles. So that means Pat's going to drive 180 miles. We also know that we have some rate for Pat, and James is going to go 5 miles per hour faster than that. So he's going to go x plus 5. If the total driving time is 5 hours, that means I should be able to add these two columns up together and get 5. Well, to get this column, we remember that time is equal to distance divided by rate. So 130 divided by x plus 5, and 180 divided by x. So I'm going to add those two together, and they equal 5 hours. Remember, one trick to getting rid of fractions is to multiply the whole equation by the common denominator. So multiplying this piece by this, the x plus 5 cancels, but the x times is to the 130. The x cancels, but the x plus 5 times is to the 180. And on this one, neither of them cancel, so I get 5x times x plus 5. 130x plus 180x plus 900 equals 5x squared plus 25x. Pulling everything to the same side, so minus 900, minus 900, minus 180x, minus 180x, minus 130x, minus 130x, 0 equals 5x squared. 25 minus 180 minus 130 is negative 285x minus 900. We can actually factor out a 5. So we get x squared minus 57x minus 180. So now I want factors that add to equal, or times to equal negative 180, that add to equal negative 57. So what this factors to become is x minus 60, x plus 3. Remembering our zero factor property, we set both equal to 0. So x can equal 60 or x can equal negative 3. Well, let's think about this. Can Pat go a negative rate? No, so we throw that answer out. That doesn't make sense. So Pat is going 60 miles per hour, because if we remember back at the beginning, Pat was going x for her rate. Well, x is 60. So Pat's going 60 miles an hour. James, on the other hand, is going 5 miles an hour faster than x, or faster than Pat. So James is going 65 miles per hour.